Okay, here's a much nicer version of the matter tree that I scribbled for you the last recording that I ended with. You have matter at the top, and then you have the two types of mixtures. Homogeneous, remember they look the same. Black coffee, unsweetened tea with no ice in it. Heterogeneous mixtures, they're going to look different throughout. These can be separated. You can boil off that tea. But substances, on the other hand, those are chemically combined like compounds. Two oxygens are joined together, fused together to make the gaseous oxygen that we breathe. Those are going to be compounds or elements, like in the periodic table, the simplest kind of pure substances. These are going to have to be separated down into the protons, electrons, and neutrons that make them up, or separated by nuclear means, like in a nuclear reactor. All right, and then we get to scientific measurement. This is a biggie. We're going to use this a whole lot. You need to know your metric base units. The metric base units would be mass, temperature, and then you need to know what a derived unit is. Now, the difference between a base unit is you have, it's the simplest kind that there is. You need a balance to measure mass with. You need a ruler to measure length with. With derived units, you have to have an instrument perhaps, but then you have to manipulate it like volume. You need 3 lengths, and then you need to multiply them together. Or density, you need both mass and volume, and then you need to divide those two. So derived, you have to do more with them. That's the difference between a base unit and a derived unit, guys. All right, so here are your base units, the most simple of them all: length, mass, time, current, which we will not use in this Chem 1. When you get to Chem 2, you'll have to care about that. Temperature. Now, the SI unit for temperature is actually Kelvin. Now, we're way more familiar with Celsius, and we're going to learn how to switch from Celsius to Kelvin. But the actual metric base unit for temperature is Kelvin. And then how much of a substance there are, how many particles are actually there. The chemistry term for that is a mole. And then candela is for how bright something is, the luminosity. Again, you won't have to know that for Chem 1. That's in higher levels of chemistry than we'll use, so that one we won't have to worry about. The ones you will be responsible for, again, are you will need to know the base quantity, the unit and the symbol for length, for mass, for time, for temperature, and for the amount of substance. These are the ones that you will be held responsible for. You're good? All right, and then you're also going to know these metric prefixes. You need to know what mega means. Mega means you have 1,000,000 of something. Kilo means you have 1,000. I'm not as concerned that you know all the rest of these for right now, but I do care that you for sure know. I didn't mean for it to do that. That kilogram means that you have 1,000 of something. Yeah. Trying to get back to that one screen. Told you this would be like it was really real live in the classroom. I would be making these mistakes too. Okay, so I want you to know mega means 1,000,000 of something. So if you have a megagram, it means you have 1,000,000 grams. Kilo means I have 1,000 of those things. 1,000. You don't have to know deci, but centi. Centi is easy to remember. It means 100th. So it takes 100 centigrams or centimeters to equal 1 meter. I also want you to know milli and micro. Now in physics you need nano as well, but we will not use those so much. But so there's only 5 of them. Now you can refer back to this table if it asks you in your homework to do others, but for testing purposes and other purposes like for quizzing, these are the main ones that you will use in physics. In chemistry in this course. So those are the ones I'm going to expect you to know. All right, and so here's mass. Kilogram is 1,000 grams. We're going to learn how to use those here shortly. And then the 2 temperature scales that I was referring to a while ago. We are mostly concerned in chemistry with Celsius. Most of our thermometers are in the Celsius scale. Those are the ones that we're most familiar with. I also want you to know the freezing point and the boiling point of water on that scale. Freezing point of water on the Celsius scale is 0 degrees Celsius. Boiling is 100 degrees Celsius. However, in the metric system or the SI system, it's done in kelvins, and there's a good reason for that, and that is that there are no negative numbers on the Kelvin scale. There's something called absolute zero, and absolute zero is the lowest possible temperature. It's the temperature at which theoretically, understand no one's ever gotten there, all motion stops. The particles have lost every bit of their energy, and they're no longer even wiggling. So that is absolute zero. And Lord Kelvin set that to be 0 on his temperature scale. And he went up from there. So he didn't put any negatives on his scale. So that's where it comes from. All right. And then I'm going to expect you to know this. How do you change from Celsius to Kelvin? And notice, too, that Kelvin does not have a degree on his scale. He just put a K for Kelvin. And to switch from degrees Celsius into Kelvin, you simply add 273.15. So if you have 0 degrees Celsius, which is the freezing point of water, on the Kelvin scale, it would be 273.15. That's the freezing point of water on his scale. For boiling point of water, it's 100 degrees Celsius, so on the Kelvin scale, it would be 373.15. And so forth and so on. So to go from Celsius to Kelvin, you simply add 273.15. And if you want to go from Kelvin back to Celsius, you simply subtract 273.15. And I always remember that. It's kind of easy to remember because it's alphabetical. You have to add letters to get from C to K, so you have to add 273.15 to get from Celsius to Kelvin. Now, here's your practice problem to work. Normal human body temperature can range from 36 degrees Celsius to 37 in the afternoon. Express these 2 temperatures in Kelvin. So you're going to take 36 degrees Celsius and add 273.15, and then do the same thing. 36 plus 273.15 would be 309.15, and 37 plus 273.15 would be 310.15. And it said to round it to a whole number, which they've done. And then to go from Fahrenheit. How do you go from Celsius to Fahrenheit? There is this little formula, and you are going to need to know it. And in your textbook, it gives it to you on page 11. That's where I am. And they use 5/9. For Fahrenheit, this is how I always learned it. I didn't learn it as on the bottom one there. I always use the bottom one. I use degrees Fahrenheit is equal to, and I don't use 9/5 like this. I always use 1.8, which if you put 9/5 in a calculator, you're going to find that that is 1 4/5, which is 1.8. So it's 1.8 times your degrees Celsius. So it's 1.8 times whatever your temperature is in Celsius, and then you're going to add 32. And the reason that you add 32 degrees is because that's the difference between the freezing point of water on the Celsius scale and freezing point of water on the Fahrenheit scale. So if you want to change from degrees Celsius to degrees Fahrenheit, then you're going to take your degrees Celsius, times it by 1.8, or 9/5, and then add 32 to that answer. And then if you want to go from Fahrenheit to Celsius, you would reverse that. You'd take your Fahrenheit, you'd subtract 32 from it, and then you divide by 1.8 and get your degrees Celsius. So that's how I would do it. It's a little bit different than what that says. I would take degrees Celsius is equal to my degrees Fahrenheit minus 32 divided by 1.8, which is a little bit different than the way they have it. But to me, it's a little bit easier than having to deal with the fraction there. All right, that's how I would do it. And you're welcome to do it the way they have, and they're going to give us, I feel like, a sample problem. Yep, body is at 39 degrees Celsius, constitutes a high fever. Convert this to the Fahrenheit scale. And so it gives it to us in Celsius, so we're going to say Celsius times 9/5, which is 1.8, and then we're going to add 32 to it. It tells you exactly how to do there. So that's 102.2 degrees Fahrenheit. 1.8 times 39, and then you're going to add 32 to that. See how that works? The others that it gives us there, other derived units are volume and density. These are so important, and they'll be one of your first labs that you're going to do as a density lab. I do believe if those of you that are taking the density, that'll be one of the first labs I believe that you're going to get. Many things like volume and density that require units that are not included in the base units, and so they're derived, which I already said that. To find volume, you need to take length and the width and the height, and then you're going to multiply them. And then to find density, in my opinion, the most useful and important things that you're going to use in chemistry, you're going to take mass and you're going to divide it by volume. And it's so important because it's used in all different kinds of things. It's used to identify substances. It's used to convert between mass and volume. It's used to eliminate mass a lot of times to change and find out how much volume you have if you have, say, an unknown. So it's very, very useful. Its units are grams per milliliter for liquids or grams per cubic centimeter for solids. Look at how all of these are equal to each other. Oh my gosh, I've gone over my time. Look at how all of these are similar to each other. Grams per cubic centimeter, this would be for solids. Look at this. This tells you right here that a cubic centimeter is the exact same thing to a milliliter. You need to know that. A cubic centimeter, or a cc for short, is the same exact thing as a milliliter. You use cubic centimeters if we're talking about solids. You use milliliters for liquid measures. We're going to do some work with density. And it asks you right here in your first sample problem for volume right here to find the density. If you're given the mass and you're given the the length on each side, a cube on each side, so you're going to take this cube right here, 2 centimeters on each side. So you're going to find its volume. 2 times 2 times 2 is 8 cubic centimeters. And you're given the mass. Find the density. Okay? So you'd say 7.36 divided by 2. And it tells you how to do that on the next page. Okay? And it shows you how to do that right there. 0.92 grams per cubic centimeter, and it gives you how to solve if you're given the density and you're given the mass, how would you find the volume? We're going to work some more of those too. All right. I'll work some more of those for you, and you're going to for sure have some more of those, and I'm sure I'll be hearing from you about those.